Hello, everybody, and welcome to another episode of the Modern Web Podcast. My name is Rob Ocel. Today, we're extremely excited to talk about state charts and XState with David Khourshid. You might know him better on Twitter as David K. Piano. I think my heart was broken when I realized that wasn't his actual last name, that he has a different last name. But yeah. David is a software developer at Microsoft and the creator and maintainer of XState. So, David, how are you doing?
I'm doing great. How are you?
I'm doing great. Now, I should say at the top that I was just joking with David that today's episode is a little bit of a lost episode. So we had a little bit of a snafu with the recording from the previous episode. So this is actually David's and my second conversation, and we hope that you enjoy it even more than the first that you will never hear. Yeah. But before we dive into XState in specific, first I just want to give a shout out to one of our sponsors for today's episode. So today's sponsor is Syncfusion. Essential Js2 is a web UI component suite of Syncfusion that offers more than 65 plus modern UI components on all major web frameworks such as Angular, React, Vue, JavaScript, ASP.NET Core, ASP.NET MVC, and Blazor. You can start to build and deliver the high-performing and responsive web apps faster with great user experience. And you can learn more about this at syncfusion.com/modernweb. And I should mention for anybody that's watching the video of this is one of their awesome swag Syncfusion shirts. So thank you so much for sharing that with us as well. All right, so jumping into XState and talking about state machines and state charts. This is something that has been really fascinating to me and a huge interest of mine for the last several years. But today, as we're recording this, is a kind of a big day as everybody is pouring through the state of JavaScript results, and XState made it to the list. So first of all, David, congratulations that you have made the state of JavaScript. That means that you've made it. You're famous now.
Yeah, thank you. Yeah. Last year, it was a popular write-in, I think top 10, but then I guess we had a lot more momentum this year, and yeah.
So the one thing that I wanted to call out, right, is that although it's awesome to make it, the biggest slice is still people that are unfamiliar with the library. So this is still a library that people are learning about, and it's being evangelized, and people are finding that they love it, and that's why it's showing up on the list now. But there are still going to be a lot of people that are listening to us talk that are like, okay, maybe I've heard of a state machine back in college, but I've certainly never heard of XState. So could you give us a little bit of an introduction to kind of what is XState and kind of why you decided to write it?
Sure. So XState is a library that allows you to make and implement state machines and state charts in JavaScript. And a lot of people hear that and they think, oh, okay, so it's another state management library. There are state management libraries like Redux, MobX, I guess Apollo Client had pretty good ratings in the State of JavaScript survey. But XState is a little bit different than that because it's not just state management, it's state orchestration. So it's more of a library for allowing you to precisely define how one state can transition to another state, the actions or side effects that you could perform, and also the ability to spawn other state machines. So there's a lot of things going on in XState that actually makes it quite different than the other state management solutions out there. But in short, it's a way to use state machines and state charts in JavaScript.
Yeah, one of the places where this it snapped into place for me, because honestly, as I mentioned, I went to college. I had a computer science degree in college, so I remember learning about state charts. I was also an electrical engineer. I think you had a similar background.
No, actually.
Oh no, okay, sorry. I was talking to someone else then about state charts when we had this conversation. That this is a big part of electrical engineering and computer engineering curriculum, is talking about kind of how to do this sort of binary addition and state charts, and kind of how a lot of that falls down from the way that our computers are built these days. And I'd always sort of just left it there and never really thought much about it until I had started to see Ryan Florence talking about building Reach UI, and he shared a state chart at a state machine that he was working on for a tooltip. So you think like a tooltip, maybe seemingly one of the simplest concepts ever. You hover over something and then a box appears that describes it. How complicated is that? You just need one Boolean, shown or not shown, right? And what he displayed was that there are so many different types of inputs, whether they be touch inputs or hovers or tabs, and you need to account for animations for hiding and showing. And if something's fading out, if somebody goes back to it, you want to instantly show it again and maybe not fade it in all the way. And it was an elaborate state chart that covered a lot of cases, and you didn't have to read the code that turned into. And I just thought that was such a powerful illustration of these tools. I mean, I don't know if you have any other examples that spring to mind where people don't expect these things to show up.
Right, and I think that's actually a great example because logic spans a lot more than just a Boolean value. Another classic example I'd like to give is fetching data. A lot of people are completely satisfied with a nice isLoading variable. It's either loading or it's not. So what I typically like to ask is, what does isLoading false mean? Does it mean that the data already loaded? Does it mean that the data didn't load yet? Does it mean that an error happened? Like, there's so many possibilities. And the typical solution is just, okay, add another Boolean value. And so this just goes to show that the logic that we put in our computer programs is just orchestrated by all of these Boolean variables. Like that's a natural way to do it. And we have a lot of if statements, like just trying to organize logic. But because of that, it's not clear what your software can do. The features aren't clear. The logic isn't clear. And so that's what state machines and state charts purports to solve. So yeah, that's a good example, though, with the tooltips.
Yeah, I think he went on further to describe that they had some additional conversations for accessibility purposes about what would be the right way to handle something. And when they decided that they needed to make add an additional state and an additional transitional state, I think it was for animation purposes, they were like, we just added the extra state to the state machine, no code changes, and it spun right up. And I think that's maybe one of the other selling points is that, so often people throw around the terms functional and imperative, or declarative, and imperative, that I don't know that the terms really have as much meaning anymore to people. But in some ways, I feel like this is echoes of that conversation, where the power sometimes of these state machines is that you can sometimes make pretty complex changes pretty simply by adjusting some of these transitions or the guards for those transitions without having to go and find all the places in your code where you would have had checks and protections against that state and fit it in.
Right, yeah, and that's because, like, as much of a learning curve as state machines and state charts are, it's really just a simplification of everything into what's called a directed graph. So, with a graph and graph theory, you have nodes and edges. So the edges are the arrows between the nodes. And with a state machine or state chart, the nodes represents different states. Now, something that's also a directed graph is a map. Like, let's say you need to get from point A to point B, right? So just like the example you were talking about, you would say, just put it in Google Maps and it'll find me a nice straightforward path from my house to wherever I need to go. But let's say that you need to do something else, like you need to pick up groceries or, visit a friend's house. Well, maybe not right now because it's COVID times, but, do something like that. Then, like the routes, the mapping between the routes don't change. It's just, okay, we have a little detour here, and then we go to the final state that we have to be in. So state machines and state charts provide that underlying language of your application logic is just a directed graph. If you want to add a feature, that's just a new node of maybe a couple new transitions. If you want to change a feature, that's just changing the transition. So it's like, just like everything is made up of molecules and atoms, everything in software is made up of states, events, and transitions.
It's funny because to me, that's why I've never fully understood the comparison between XState and libraries such as Redux. I think you're right when you pointed it out earlier that this is one way to manage state. XState certainly is that. But I've always seen XState as being more analogous to a library such as RxJS. So something that more looks like transforming events into observables, and that sort of like higher level consideration of just taking all the various inputs into your system, sort of ordering them as these streams and being able to get that kind of control over it, that the sort of much more declarative definition of kind of how you want to react to stimuli from your toolbox, from your UI, from your users. And I always thought that that was just a much closer analogy to XState, and I thought that maybe the two libraries even would make a pretty good pairing in a lot of systems. But I don't know, what are your thoughts on that? Like, do you enjoy kind of people asking, should I use Redux or XState? Or, do you kind of feel like that's sort of asking the wrong question?
No, it's actually not so much the wrong question. There's, I've been meaning to make like an alignment chart or like a sort of graph of like just the different state management libraries. But I think of it in terms of two axes. I think of it in manipulating states directly, which is libraries such as MobX, Recoil, just libraries like that. And managing state with events, which would be closer to Redux and XState. And that's why I actually say that Redux and XState are pretty similar. But then there's also the topic of having a single global store versus multiple stores that each communicate with each other and they could create each other, things like that. Redux is very much in the single atomic global store camp, and XState differs a lot by, allowing it to be used, at a component level or having a system of many stores that communicate with each other. So there's a difference there. With regard to RxJS, there's similarities too, because RxJS can be thought of as a stream of events. And what those events are, loosely defined, they could be things such as just value changes or even explicit events like you would have in Redux. But RxJS is much lower level than XState in that you could use something like RxJS to build an XState. And in fact, XState is fully compatible with RxJS because the interpreted machines are subscribable. So they're observables, really. And so, you could use them together. But RxJS is just the streams, just the plumbing. And it's like Lodash for those observables. And XState just uses that concept of a stream of events and, adds some structure around it.
To be honest, I think that's part of the reason why XState is taking off so well, is that, it's been said, or it is true, that state machines are not new, right? This is a concept kind of almost as old as computing, in some cases older than computing, depending on how you define it. So, state machines are not new. And they're certainly not even new in software development. Other disciplines, other languages, other ways of building software have done this forever. Mm-hmm. But what I think is so exciting, I think why this catches on so well with people, is that it does hook in really nicely with all the frameworks, right? So because it's observables, it hooks up super nicely with Svelte and Angular. It has library bindings for React and for Vue, which kind of makes XState, and then you can just choose to do it yourself, either in vanilla mode or by integrating into these libraries itself. So I don't know if you want to speak to that a little bit about just how it's been. I don't know if this was intentional on the way that you designed things or whether it just works out that it just fits really nicely into the existing models of the other frameworks that people are using right now.
Well, yeah, you probably know that I used to be really huge, and actually I still am really huge on just observables, right? Just this idea of a stream of values. Like, I think that promises are not sufficient because promises are like you might get one value eventually, and observables represent there's many possible values that you could get over time. And so I'm like, all programs can be described closer to that idea, like just things change over time and you get this like stream of values. So frameworks such as Svelte naturally play well with this. And in fact, I was really excited to see Svelte so high on the charts in the State of JS survey. I played around with it a little. In fact, I made a template for XState and Svelte, and I didn't even need to write a custom hooker. Actually, I think I did, but it was like very, very thin. It just plays really well with Svelte stores because, Svelte naturally operates on that reactive principle. So like the way I designed XState was actually with no framework in mind. In fact, when I first created XState, it was not even meant to be used for anything. I was just playing around with, all right, how can I describe state charts with, just with JavaScript, regardless of framework? And then, it didn't come until later that I thought, like, maybe I should start writing some integrations for these frameworks. The most painful one was React. React has some funny things going on with hooks. But yeah, and Angular actually, because XState services are observable, it actually integrates pretty well with Angular without any extra tooling.
Yeah, so even if it was just an accident, it certainly is a happy accident. I think, again, that's why people they just, I think anytime it's difficult to integrate a new library, people kind of go, it's really going to have to prove itself. But when it just slots in, people are kind of like, oh, I'll try it a bit. I can play around with it a little bit. Thinking about people. So we talked about people that do the is loading. Is loading, is errored, and then they'll like say, okay, well, error maybe take precedence over loading, and I'll code that into my template logic, and I'll try to make sure that all these things stay in sync, and all of that happens. But I think one of the things that people have been advocating, that have sort of been pushing for either XState or just state machines and state charts in general, is, okay, at a minimum, make 2021 the year that you stop using the Booleans. Let's switch over at least to using sort of enumerations. And so I think a lot of people have been moving that way to if you're not going to do a full-blown state chart or full-blown state machine, at least just code the states in enumerations. But when people are kind of going, okay, great, I got rid of all my Booleans, I have my enumerations, what is the next step for these people? So they bought in, their team loves it. What is the next step in the direction of state machines for them? Like, what is the problem they should be looking out for? What is the thing they should be keeping in mind that's an indicator to them that they might want a hardier solution or to take the next step in their adoption of state charts?
So using enums instead of Booleans is the finite state part of finite state machines. However, like defining all of these different states is sort of, I don't want to say useless, but it's less useful without having a declarative way of defining how you could go between those states, right? It's sort of like saying, there's all these countries in the world, but if you don't have a way to travel between those countries, then what's the use, right? So the next thing would be like just defining those transitions. And normally in code, you would do this in sort of an ad hoc way, like you would directly set the states, but then you're copying logic all over the place with that, and it's sort of a messy approach. And so that's why you would have switch statements. And this is something that I'm actually really glad that Redux popularized, is the fact that your state and your logic for changing state is within a single reducer. So when you receive an event, only that reducer can tell you what the next state is going to be. So the logic is centralized. So that's a good approach, using switch statements. I would say on top of that, you would use switch statements on the finite states, not the events. The typical way of doing things in Redux is switching on the events type. And with XState, you can think of it as switching instead on the finite states and then the events type. And obviously, that's really verbose to type, which is why XState has that object DSL. So yeah, that would be the next step, is defining those transitions. And then you're pretty much most of the way there.
Yeah, and what I like about that is because that is why I find kind of the modeling tool that XState has. Like, if you've never used XState in a library, just using the modeling tool to draw these state machines and using that in your design documentation, that's just a value add, period. So if you're listening to this and you're saying, I'm not allowed to bring this library in, somebody doesn't like it, at least just use the visualizer to draw these things and start putting them into your designs. People will start falling in love with them, and then like, hey, doesn't this work with code? But I love this idea that you can define the transitions, and then you could fire any sequence of events you wanted to. And the state guards, the transitions and the guards on them will just protect you. Like it's that kind of sort of like idempotency, like the fact that you can just rest assured that no matter what sequence of things they're going to throw at it, you have a predictable and readable model of what's going to come out of it. As a developer, it reduces the complexity of what you're implementing so much to know all I have to do is faithfully bind the state machine to the UI and the places I expect it to bind it. And I can just be confident the rest works because I took care of the hard stuff outside of the code. And I did the easy part in the code, the easier to test, easier to verify part.
Right, yeah. And well, what's funny is I was actually talking to some colleagues at Microsoft about this, but just the idea of like a framework agnostic component, right? And if you really think of what a component is, it's it's just a thing that is rendered based on the state, and it's also things that, you know, the user could do things to. So like take a button, for example, you could click on the button, you could hover over it, like all of those are events. And so those events cause a change in state, and they might also cause like effects to, or like actions to happen. And so basically your UI and I mean, regardless of if you're using state machines and state charts in the front end or back end, like just this idea that your programs can be defined as a sequence of events, like you said, it really, really simplifies things. So.
Yeah, absolutely. So, okay, so now we've moved over, we're kind of using the FSM. So I think, you know, we didn't make reference to this, but I believe it's XState FSM. Is that accurate? The sort of the quote unquote no frills version to just get some of the quick and dirty stuff in there?
Yeah, the flat version. So no nesting, no parallel states. Yeah.
Right. So so far that's kind of what we've talked about, right? And maybe that's as far as people have ever seen state machines. But the thing is as with anything in life, it goes deeper. There are decades of scholarship about these things, and people have learned some really interesting ways to model some really complex situations using these state charts. So I'm kind of curious, you know, I asked you earlier, you know, what are some of the things that people should be keeping in mind as they move from the simple enumeration to using a finite state machine? But my next question is more along the lines of how do people learn what finite or what state charts can do and what XState can do when it's all the way turned on? You know, I think RxJS and observables was the same way. A lot of people don't think in observables. So watching Ben Lesh do podcasts or you know, videos where he's like, watch, let me show you how easy it is to do pull to refresh. And your mind just gets blown and you learn how to express yourself in this new methodology. How do you recommend that people sort of broaden their understanding of what state charts are even capable of doing to inspire them maybe to know when they could be using some of these more advanced features?
So one of the mistakes that I made early on in my career is just trying to be like, oh, here's this new library, like here's RxJS. Let's try to learn all of the observables and see what's possible. But that should not be the goal. State charts do have a lot of features. In fact, they're an extended formalism on top of state machines. And so you have things such as hierarchy with nested states, orthogonality with parallel states, history, broadcast communication, etc. But you shouldn't be trying to learn all of those features. I would say like the important thing is just what you said, like learning to think in, well, like not in observables, but in state machines. And honestly, the simplest way to do that is like, once you learn what those three basic components are, a state or finite state, an event, and a transition, grab a pencil and paper, grab a whiteboard and marker, starts drawing out your logic. And you're going to find that it's actually really intuitive. So when you're trying to make a new feature, you're going to say, okay, so it could be in this state, but then if the user clicks this, or if this happens, then it's in this state, and that state has its own set of behaviors, and this other state has its own set of behaviors. You start drawing those out, and you start, just understanding the logic by just looking at the diagram, and then you just translate that to code. And so that's what I want people to learn, whether they use XState or another library, or even if they use no library at all. Like just the idea that your application is made up of these state machines, and you should start thinking in terms of state machines instead of whatever ad hoc logic we were doing. I can't even think of it right now because like I've been doing state machines for so long that I look at old code and I'm like, why are there so many if statements and Booleans? Like I cannot understand this at all. So
absolutely,
change some thinking.
Yeah, and it's one of those things that once it clicks, you're not even going to realize that it clicks. You know, I sometimes tell people like learning languages. I like to joke that I studied 2 languages when I was younger, and in one of them, it stuck with me, and I said it was because I got to the point where I could dream in that one, and in the other one, I could only speak it. And I always use that as sort of as a joke. It's like sometimes when your brain finally switches over to kind of be able to think in that other way, it is really pretty powerful. When you start seeing things from a different angle, and now suddenly problems that were sort of really difficult become really simple because you can break it down a different way.
Yeah, and that's the thing that actually seems or seemed the most unlikely to me with XState was that so many people were using it. I was completely expecting it to be a niche library for the longest time. Just anyone who was interested in the same, state machine, state chart niches I was interested in, like that academia, whatever. But it really is like that. Once you start thinking in state machines and state charts, it's really hard to, not see your logic in that way. And so, that's why I like to joke that XState is like Redux with rules. So if you didn't think Redux had, well, all right, so XState has considerably less boilerplate than Redux, but XState has also a lot more rules than Redux. And so if I were to advertise XState as, oh yeah, it's Redux, but you have to learn all of these extra rules in computer science terms, I don't see why anyone would adopt it. But once they start thinking in it, they're like, hey, these constraints actually make sense for the logic that we're trying to do. So yeah, it's sort of a mind twist.
Well, and for anybody listening here, because it requires a different way of thinking, it shouldn't be confused that this is actually difficult. So what's interesting is that one of the libraries that I recommend that people use if their team is comprised of juniors or has juniors on it or any number of juniors on it is XState. And part of the reason for that is because one of the things that I encounter a lot when I'm mentoring people that are more junior in development is that oftentimes the questions they ask is, I'm trying to get, Angular to do this. Mm-hmm. I'm trying to get this variable to be represented like this. And you always have to sit down with them first and go, no, okay, forget the framework. Just tell me in terms of what you see on the screen, what you want to have happen, and in which scenarios you want that to happen. And then you talk through that, and then you go, okay, now let's find a way to bind that or turn that into Angular code. Mm-hmm. And teaching people to think that way is a really critical first step. And again, that's why I recommend this library to people. It's not an advanced library. It's actually kind of the opposite. It lets you take it helps you separate the syntax of the framework or the tool that you're using from the definition and the understanding of the business logic. So this is, even though it sounds heady, even though maybe some of the terms you're hearing, you're like, I didn't take CS in college. Can I even get there? Trust me, this is an approachable methodology. It's an approachable library, and it might even be better for understandability than not using it.
Mm-hmm. And in fact, I'll tell you some of the things that I like doing with XState. Honestly, I'm a really lazy developer, so I like being lazy as much as I can. And so when I'm using XState to create logic, you have to add implementation details such as like, okay, what does doing this action actually mean? How are you going to call this service? But at the beginning, when I'm just designing everything, I just put a string. It's like make WebSocket connection, I'll just put it as a string there. And that's totally valid with XState. And so that's basically a placeholder of like, here's where the implementation for this action goes. And so you could really be as lazy as you want with XState, describe it completely as text, in fact, completely as JSON, and then later add the implementation details. And this actually allows you to use the exact same machine in many frameworks because all that changes are the implementation details. The logic is the same. The actions might be a little bit different, but otherwise everything is still the same.
So that's a perfect segue to a question that I've been curious about. And I don't know if I've seen plans for this or, I don't want you to spoil any announcements or anything like that. But another library I really love is Tailwind. And one of the big cool advancements of Tailwind in 2020 was the release of Tailwind UI. So this ability to share snippets of Tailwind code that represent certain components that could both inspire people and speed people up. So we've talked about XState, the fact that this is sort of framework agnostic, also that they are portable. They don't rely on a centralized universal state machine necessarily. So is there been talk about like NPM for XState, like an XState repository or a way for people to share or inspire others with kind of their solutions for typical development problems?
Yeah, in fact, that sort of is the next logical step for, I have a website at statecharts.io. I made that website to serve as a placeholder for basically all of the things that I want to create with XState. The first one, the most major one, being the inspector, which allows you to visualize your state machines in your live running application, either in a different screen or in an iframe. and you could see the machine working. And what's crazier is that you could even interact with that visualization and see things happen in the app. So it's sort of a two-way thing. But what I really also want to do is, basically have that repository of just state machines that people can share and people can use within their organization or their teams, and customize to their needs. And like, for example, let's say that you're working on an app and your PM tells you to add a dreaded drag drop feature to the list. And you're like, oh man, like, all right, I'll try to find a library that does it. All right, this doesn't exactly do what I need. We have a lot of custom things that we need to add. I want it to be simple to just, go to this magical state chart library, be like, give me a drag drop machine. It's framework agnostic. So all I have to do is plug in the events, read the state, and that's it. Like, in fact, that's the process that would work for pretty much any machine. You send it events, you receive state, and that's how the machine works. And just be able to copy paste that machine right into your code and have it work exactly as you want. And then if you need to add anything custom, then you just add the machine, because again, it's like we were talking about earlier. These are all just nodes and edges connected to each other. If you want to add a feature, change a feature, you're just moving arrows and nodes. You're not doing anything crazy. And so that's something that I feel like is the problem with a lot of libraries today, is that they're not framework agnostic. They're either like purpose built for a specific framework, and also the features, the things that the libraries allow you to do, is very set in stone. You could propose different behavior, but if it's accepted, best case scenario, that adds complexity to the library, which introduces a lot of bugs. And worst case and most typical case scenario, the maintainer just goes like, no, I'm not going to support that. Go ahead and fork it and try to figure out yourself. And that's not good. So we do need a more extensible way of sharing logic, not sharing components, but sharing logic, because I feel like that's the next step in web development programming in the future.
I'm with you. And I was going to say the same thing. I love it, because the one thing that I'm thinking about here is accessibility.
Yeah.
It's not that accessibility is unknowable, but it is very difficult for people that have never either implemented it or never experienced or just don't remember experiencing any sort of form of disability, right? Because some disability is permanent and other types are temporary. And we might not even think about that, right? Like you break your hand and suddenly you have to type with your other hand or things like that. Right. And so what I love about it is that you can share with someone that skeleton, that business logic, that interaction skeleton that includes those hooks for accessibility directly into them, that you might not even realize, had not even thought of, oh, what would this be like if somebody needed a touch interface for it? And so you're right, not at the level of components. This would slot inside of any component library you're building yourself or any component library that you're integrating into. I think that is going to be a huge win for a lot of people that advocate for developers doing things that will make their users' lives better, or just make their tools accessible at all. So I'm with you on just being excited for what people are going to be able to share with each other and what people are going to be able to enforce by sharing these sort of things like a state machine.
Yeah, and I completely agree with you. Accessibility is not easy, and it's really, really important. Reach UI has done a lot of work with components with a huge focus on accessibility. And Redux UI, if you've heard of that from the team at Modules, has done similar things, just making sure all of their custom components like combo boxes, dropdowns, whatever, are all completely accessible, and they follow those WCAG guidelines. There's a reason that no one really does this when making custom components, is that it's just really complex to do. And the thing with Redux UI and also Reach UI, they both at some level also use state machines and state charts. And they do that to basically make sense of the accessibility. And I know we tend to, this might be biased, but we tend to think of accessibility in terms of like I don't need to bother with that. Like, I'm sure that there's a small percentage of people who need this, but if I omit it, then whatever. Something I do want to emphasize, and this is sort of off topic, but it's that accessibility is for everyone. I know that I would be pissed off if I I was typing in a form, I press tab and nothing happens, right? Or if autocomplete didn't work, or if clicking a label didn't focus on the right input, or if everything had to be done by mouse. I like being very keyboard heavy. So if I have to click everything, that's just really annoying. Actually, there was an issue. I had a MacBook Pro where the screen just wouldn't turn on, but I needed to, do some stuff to it to fix it. And using the screen reader technology actually saved my butt on that. So in short, like even if you're fully able, accessibility is for everyone, and it's something that's hugely important to focus on.
Well said. Yeah, and anything that can make it more available to people to help them learn. Because again, I find that it's not that people, the majority of developers I've spoken to, it's not that they're opposed to it. They just never been taught it, and it's not something they can intuitively understand, like many other types of things. So it's difficult, but it's worth it, and it's important that people do it and that people enforce it on their teams. And again, this is one way that if you're a tech leader in your organization or on your team, these state machines can be one of the ways that you can help spread that knowledge and enforce that behavior. One of the things that I wanted to spin off on, which is funny because you mentioned Reach UI uses state machines, and I was just corrected about this on Twitter recently. I had mistakenly believed that they were using XState because I could have sworn that what they had shared on Twitter was an XState visualization. And, and it might well have been, but they were using kind of their own implementation, a compliant implementation of the state machines. And I think that was something that was worth calling out here. You've mentioned it sort of in passing a couple times, but XState is not a reimagining of state machines. It's not a totally unique standard. It's built on the shoulders of a lot of academia, a lot of papers. And so even if you're afraid of committing to any one library, I mean, what's great about using this is that it is built on a standard. So I don't know if you wanted to speak to that at all.
Right, yeah. The important thing is that these ideas carry over. XState isn't the first state machine library in JavaScript. It's definitely not the last one. There have been a few recent ones which are actually pretty cool in their own rights. But XState does follow SCXML, and it tries to adhere to it as closely as possible. By the way, SCXML stands for States Chart XML. It was a standard, a W3C recommendation that was published in 2015. So quite a while ago now. Feels like forever ago. So SCXML defines a standard for just everything having to do with state charts, parallel, nested states, transitions, invoke. And so if you actually read that spec, you will unintentionally learn XState just because so many of the things are the same. And that's because XState tries to stay compatible with SCXML. And that's actually on purpose. First of all, like I said, lazy developer, I don't want to have to think of these new things. I would rather there's a spec that tells me exactly what to do. Perfect. I will just follow it. Secondly, there's implementations of SCXML in other languages too, such as Java, Python, C++, I believe. Since this is a standard, they could just implement it as is. And so what that means is that XState could theoretically create state machines, have it converted to SCXML, and have that be interpreted by other languages. So not only is it framework agnostic, it's language agnostic as well. And third, just like you said, the ideas carry over to whatever state machine language you're using. Like you can't exactly, all right, so MobX is a really great library, but you can't exactly carry over whatever you're doing in MobX to something like Vuex, despite the similarity in names. Like it's just two completely different worlds. But anything you do in XState, if there's another state machine library, you could just basically copy paste the same things over. It's the same ideas. And so that's why, it's completely natural that both Redux and Reach UI have their own state machine implementations, partly for size reasons, partly because they don't want all the features that are in XState, which is totally understandable. But the ideas are exactly the same. And in fact, with Reach UI, I think you could even copy and paste the exact same objects, put it in the XState visualizer, and it's going to visualize the same machine, despite it not being written in XState. And so that's on purpose.
Great. So We're here at the beginning of 2021. It's always a time for sort of looking forward, for planning, for resolutions. I mean, you mentioned State Chart IO and some of the things that you have planned, if not for this year, for the future. Is there anything else that you wanted to kind of get people excited about, either new scholarship you've read about state machines and state charts, or just things that you have planned for XState and the XState community?
There's so many things I have planned for XState in so little time. One of the big things, like we talked about, is just having a repository of machines where people can freely use and share with other people, basically like a library, right? Just a shared collective of state machine knowledge. Also, I want to take the inspector to the next level. So something that I've been working on for a few months and still working on, hopefully releasing a alpha soon, is a state chart creator, which allows you to visually create these state charts instead of having to code them up. And it will generate code. So if you want to physically add more code to it, then you totally can. It works in both directions. But I think that that's a natural next step for being able to visually create your state charts. And then let's see, more testing tools. I'm also working on XState version 5. And by me, I mean like me and a couple other contributors on the XState project. Thankfully, I do have some help there. I just have a ton of ideas, things I've shared at Reactathon. Like actually, a lot of things that I've shared in previous talks, Reactive Conf, Reactathon, some other conferences are all just like future ideas that I want to implement one day. So one of the things that I shared at Reactathon was the idea of taking an application that uses XState and being able to generate not only documentation for like just everything that you could do in the app, but also generating these flows in a visual way. So take a shopping cart app, for example. If you want to show the user, here's how you basically check out and get to the checkout page, it will render the app at each one of those states and show you exactly how to get there without any manual effort from the developer. So it's all auto-generated. And
I remember this talk. I don't know if it's the exact talk you're talking about, but I remember watching one of your talks about the potential for automatic code and automatic test generation, and that blew my mind. It's just the possibilities of that, to feed a state machine into a tool and have it say, okay, let me manipulate your tool. This is how I send this signal. This is how I send this signal. Now let me walk through all the states of the system, and including the impossible ones, make sure the system's responding correctly. Very cool potential there. For correctness, in an environment where we've often been jokingly said that software engineering is the least engineering of the engineering disciplines. Any ways to get more correctness and more provability to our systems, is kind of a cool benefit for sure.
Right. Yeah. I say that's basically bringing engineering into software engineering in a way.
I love it. So. In conclusion, sort of the last question that I had for you, and I guess on a bit more meta level, is, I was reading, catching up on your Twitter in advance of this, and I saw that one of your resolutions for this year was to do even more work affecting sort of users and customers, and not necessarily just in developer experience, which led me to sort of think, it's sort of an interesting thought. I just saw another sort of thread in response to State of JavaScript by Kent C. Dodds, who was kind of, him and Ryan Florence were sort of remarking like, hey, Kent, did you ever think that you were just going to become the testing guy? Like, of all the things that you could have been known for, like, did you think you would be the testing guy? So I guess my kind of question is did you think you were going to become the state machine guy? Sort of, what do you think about that? Sort of, I'm sure you're appreciative, but like, how, is that crazy to you? Or like, where do you see that going in the future?
It is crazy because, from my very first big boy development job, like I've been thinking of just using state machines and learning more about them, and I thought that it would be just a really niche interest. In fact, one of my first forays into state machines was just reading this Introduction to Computation and Finite Automata, or like just this really math heavy textbook on just learning about this stuff. And so I was like, basically no one is going to read this for fun. So I thought like that would have been a niche topic, and I would be more like just the person advocating animations, which, to be fair, like I still try to do that. And in fact, we have a show called The Keyframers every week, and I think we're actually doing a stream today. But basically, we try to merge state machines and animations together and just show developers how you could use state machines to make animations more reasonable, more readable, and easier to code. So yeah, animations are also a huge one of my interests, and I feel like that's what I was known for before state machines. So.
And somewhere back there was music involved, you know?
Oh, so. Yeah, that's a piano in my name, so.
That's great. So that's pretty much it for today. I mean, I think I will end with one more thing, is we love to reach out to people, especially people that are aspiring software developers, and just say that, you know, if anything that you heard today inspired you and you feel like you want to bring it to a local meetup or give a talk or write a blog on it, I can personally vouch for the fact that David and the rest of the XState community is one of the most supportive on tracking when people are doing these things, supporting them, maybe even showing up in the comment section sometimes if it's an online event. It's a really cool, really supportive community. So if you're looking for a place to sort of jump in and just sort of meet people and kind of get involved, this is definitely one of them that you should be looking at. So I don't know, David, if you had anything specific that you wanted to point them to if people were just looking to kind of get into sort of the community generally.
Yeah, well, we do have a community on spectrum.chat/statecharts, sort of moving away from that, though, seeing where we're going to end up next. GitHub has discussions now, so you could go to XState, davidkpiano/XState/discussions and just freely talk in there. We also have a Gitter chat at, I think it's statecharts, I don't know the exact URL. And pretty soon we're going to be getting a Discord, because I feel like that's also the natural next step. So, yeah.
That is the next thing. All right. Well, great. That's it for today. Thank you, everyone, for listening to this Modern Web podcast on state charts and state machines and XState. And thank you, of course, to our guest, David. As always, we say the conversation does not stop here. So if you want to reach out and talk about any of the things that you heard today, feel free to find David on Twitter at DavidKPiano. That's DavidKpiano. You can find me online at Robocell. So that's ROBOCELL. As for the podcast, you can find us online at moderndotweb.com or on Twitter at modern.web. As always, thank you as well to our sponsor, Syncfusion, and we'll see you all next time. Thank you. Bye-bye.